When a headline says a solar flare is heading toward Earth, something is usually being confused. A solar flare does not travel through space like a cloud or a projectile. It is a burst of radiation. The thing that can carry a vast cloud of solar material across the solar system is a coronal mass ejection, a CME. They can erupt together, but they are not the same event. So which one actually reaches Earth? The answer depends on what we mean by reaches. A solar flare is a sudden release of magnetic energy in the sun's atmosphere. It produces radiation across the electromagnetic spectrum, including X-rays and extreme ultraviolet light. That radiation moves at the speed of light. It crosses the 150 million kilometers between the sun and Earth in about 8 minutes. When strong X-rays reach the sunlit side of Earth, they change the ionosphere and can disrupt high-frequency radio communication. There is almost no advance warning. By the time GOES satellites measure the flare near Earth, its radiation is already arriving. The flare is the immediate messenger. A coronal mass ejection, or CME, is different. It is a physical cloud of plasma threaded with magnetic fields. A large coronal mass ejection can carry billions of tons of solar material and expand across millions of kilometers. Even the fastest of these clouds move far more slowly than light. An Earth-directed CME commonly takes 1 to 3 days to arrive, and most coronal mass ejections do not hit Earth at all because they erupt in other directions. Coronagraphs such as LASCO block the bright solar disk so forecasters can see the cloud expanding, measure its speed, and estimate its direction. The CME is the slower messenger, but it can be tracked. Return to the eruption we followed in the previous episode. On October 3, 2024, GOES recorded an X9.0 flare peaking at 12:18 UTC. The associated halo CME appeared later in LASCO's field of view. NASA's event record shows a shock associated with that eruption reaching near-Earth space on October 6th at about 6:55 UTC. The brilliant flash and the expanding cloud came from the same magnetic eruption, but they crossed space as different messengers at very different speeds. So which one matters more to Earth? For an immediate radio blackout, the flare matters. Its X-rays disturb the upper atmosphere on Earth's daylight side. For a geomagnetic storm, the CME matters. If the cloud's magnetic field connects strongly with Earth's magnetic field, it can disturb the magnetosphere, intensify auroras, affect satellites and navigation, and in severe cases, interfere with power systems. A powerful flare can occur without an escaping CME if the sun's magnetic field traps the eruption. And a CME can travel away from Earth even when the flare looks spectacular from our viewpoint. Brightness alone does not tell us whether a solar storm is coming. There is also a third messenger: solar energetic particles. These high-energy protons and electrons can be accelerated during a solar eruption and may reach near-Earth space in minutes to hours. They are not the flare's light, and they are not the main body of the CME. They can produce solar radiation storms that matter especially to astronauts, spacecraft, satellites, and flights near the polar regions. One eruption can therefore send light, energetic particles and a magnetized plasma cloud, 3 messengers traveling on 3 different schedules. So here is the answer. The flare's radiation reaches Earth first. The CME's material may arrive days later, but only if the cloud is directed toward us. Energetic particles can race between them. One changes the ionosphere, one strikes Earth's magnetic shield, and one raises the radiation environment in space. That is why space weather forecasters watch more than one instrument, and why a solar flare and a CME should never be treated as 2 names for the same thing. If you want to follow the next messenger, subscribe to Galaxy 387. In the next episode, we will ask how scientists can tell whether a halo CME is truly heading toward Earth when a single camera can make direction surprisingly difficult to judge.